Hello everyone, my name is Daniel Martinez.
I'm Kevin Nguyen.
I'm Eric Soto.
And we're the team that has been working on the autonomous bin. So our main goal with this project is to design and create an autonomous trash bin that is able to take itself out every week with obstacle detection. We also wanted to be able to help a wide range of consumers, anywhere from homeowners, elderly, disabled, and as kids, as you can see.
Because we wanted to appeal to as many people as possible, we started thinking about chores we all have to do every week. And one of our team members said, we have to take out the trash every week. And we thought, maybe we don't have to. And that's how the autonomous bin was born.
Our design goals were to implement a motor system into the existing household garbage bin. As you can see, we wanted to design it to be modular, so the bottom chassis can be taken out and mounted into any garbage bin as long as it's the same size. And we're using flow encoders to measure distance and map out the travel path of the bin. We wanted to use the onboard peripherals to set the date and time, which will be controlled via the Android app. And we also integrated obstacle detection and some obstacle avoidance using the proximity sensors. You can see it mounted around the bin with circular dots. And also we implemented a solar panel charger on the top of the lid to keep the battery at optimum capacity.
So during the design process, we knew we would have to tackle some challenges that were sure to come up. The first challenge was trying to keep weight off of the motor so it wouldn't be damaged, and we solved this by mounting the wheels onto a wheel bearing so that the weight would transfer from the motor onto a chassis. And the next challenge that we had to solve was how to maximize the space inside the trash can so we could fit as much trash as possible. And we did that with wire management and by fitting all the wire pins and as many of the modules as possible onto a breadboard, pushing it all down to the bottom. And finally, we wanted to make a user-friendly interface, so we decided to make an Android application to help people with setup and with use.
This is the pictures of the project. On the top here, you can see there's the solar panel right here. And then zoomed in on this picture is the ball bearing system. So all the weight is being transferred to the ball bearing, and then it's taking the weight off the motor and transferring it to this aluminum case, which is mounted to a 3x3/4 inch plywood on the bottom of the trash can. And on the back view, we have proximity sensors all around, and on the bottom is a caster wheel to aid in maneuverability. And the front view, we have just the proximity sensors on bottom, right-hand side, left-hand side, and in the middle.
So to create the self-driving mechanism, there's a lot of components that work together to accomplish this. The brains of this whole system is the Arduino Mega. One of the most important components is on the top left is the encoder buffer. That reads information coming from the wheel encoders that's embedded into the motors, and it's able to give me data that I can interpret and then make calculations based on that for the Arduino. And then we have the time module, which is able to store the day and time even when there is no power to it. It has an external battery, and that's used so the trash can knows the day and the time that it's supposed to take itself out. There is a Bluetooth module which is able to connect to the Android app, and that's how you control it, have it memorize the path, and basically it for that. And then the ultrasonic sensors, like you mentioned, they're all around for the obstacle detection and some avoidance. We also are using an ultrasonic sensor inside the trash bin, so when the trash is empty, it knows that there's nothing inside and it can move back to its location. We have a voltage regulator, so we can send out 5 volts to the H-bridge, the Arduino, and the breadboard. The H-bridge is used to control the motors themselves. I'm able to make them go forward, reverse. And then those are the motors on the left, mounted to the plywood. And these are the batteries we use. In the current setup we have, it's only a 112-volt battery, but if you want more power, you can put 2 batteries in series, make it 24 volts. And then we also added a toggle switch, since we were testing it and we wanted to make it stop in case something went wrong, so we can just power off all the power from there.
The next slide is the Android application. On the top left, you can see that's the icon that will show up on your home screen. And once you click on that, it'll pop up this window over here. And the first thing you want to do is click on the top where it says Connect Bluetooth. And once it's connected, you can use the directional keys on the right side to control the bin. After that is done, you can store the path with the Depart Path button, and then you can move it back using the arrow keys and then record Return Path. One half of the screen is the date and time settings, and you can set the day by just clicking on Monday, Tuesday, Wednesday, Thursday, Friday, so on. And also the time, once you click on the set time, the middle screen will pop up and you can choose what time you want to set. And once everything is set, it's going to show the day and time of departure. And the return path is there, but it's not necessary because we implemented the sensor to detect when the trash will be removed. So the path is a little outdated.
So making a prototype isn't really a smooth process, and we ran into some problems that we would have to solve along the way. The first problem we ran into was the first motor and wheel encoder we bought didn't meet our needs, so we had to buy some new motors, and these are stronger, they have more torque, and they have attached wheel encoders, so they were better. And we also had a problem with the pre-installed wheels. They would be dragging and they wouldn't make smooth turns, so we added that heavy-duty caster wheel on the back. And the final problem we ran into was our wheel encoders went out during the last few weeks, and that delayed us for a while while we waited for new ones to come in.
So the final specs of this design, the main one would probably be the weight. This is restricted by the manufacturer specs on the motors. It can push about 150 pounds, and that's with 2 batteries, that would be 24 volts. The speed, at its current setup with just 1 battery, it does about 1 foot per second. This can be adjusted through the code, and it can do up to around 2 feet per second. And then the Bluetooth distance, this is important since you first set up the path through the app. So the range for that is 30 feet, so you have to be within 30 feet in order to record that path. And then the proximity sensor, it reads about 30 degrees, so putting sensors all around gives us a good view and angle of any obstacles on the way.
So our allocated project budget was roughly $1,200, and we used almost all of it. The most expensive components were the motors and the mounting hardware and the batteries, but the Arduino and the encoder buffer, the modules, the miscellaneous wires, nuts, bolts, wood were a significant part of the budget too. And we do have some, if we had more time, there are some things that we would change if we had more time and budget. We could use LiDAR for better obstacle avoidance. We could build a suspension system onto the chassis, or when the trash can gets loaded up and brought down by the truck. And we could scale, or we would scale up the trash size to pretty much the standard one that's in everybody's home. And we could use smaller batteries to reduce the weight, and they would be cheaper too.
What we accomplished this semester and last semester is finishing the Android application. We finished the path memorization algorithm. It stores the path and it can replay it with the date and time set. And also we have obstacle detection, so if there's something in the way of the path, in the way of the bin, it will stop and it won't run it over, like your dog or your car. And if future students want to take on the project, we hope that they can make an iPhone application, because most people also use iPhone, and they can improve the chassis design with a suspension system, and also improve on our obstacle avoidance network.
So overall, our design approach was enough to be able to prove that an autonomous trash bin is possible. The obstacle detection gives the homeowner a a safe environment. However, there are some improvements that must be taken in order for this to be taken to market. For example, it is not waterproof. Also, it'll be better to have one embedded system where there's no external components. It's all handled with one system in itself. And also, if there is a decline on its path and it's too heavy, it might tip over. So we have to fix that as well, especially in the driveways, which obviously have a decline. And we have a
We have a demo video, and we would also like to do a live demo.
It has been sped up a bit, so it's faster. And that's doing it on its own at that point. Alright, so now we'll do a live demo. It's actually going to go through that path. It's a small path. We didn't know how much space we had. Now it's actually checking if the trash is still there. So I'll go ahead and remove trash. And it's supposed to go back into those spots right there. And that's my driving. So anything I did while setting the path is what it's going to do. Any questions?
For the team, as I have the next team set up. Thank you.